Hey there guys, this is the 2019 Edexcel A-Level Maths Paper 2. Let's go. Number 1. Given that 2 to the x times 4 to the y is 1 over 2 root 2, express y as a function of x. Alright, so we need to write each term in the same base. So here that's 2. So we have 2 to the x. Now 4 is 2 squared. So 4 to the y is 2 to the 2y. Now on the right, 1 over 2 root 2 is 2 to the minus 3 halves. Okay, so now the indices on the left must be equal to minus 3 halves. So on the left we have x add 2y is equal to minus 3 halves. Subtract x and divide by 2 and we get y is minus x over 2 minus 3 quarters. Number 2. The speed of a small jet aircraft was measured every 5 seconds, starting from the time it turned onto a runway until the time it left the ground. The table has the results with time in seconds and speed in meters per second. Part A, using all the information, estimate the length of runway used by the jet to take off. Alright, now the mark scheme has about 7 different methods. There are a few different answers they would accept. Now, the way that I thought about it was if we drew the graph of each 5 seconds, then we would have a load of trapeziums. Now the area of the trapeziums would give us an estimate of the length or distance travelled. So, the area of a trapezium is the height times the top and bottom lengths, all divided by 2. Now each trapezium here has a height of 5, so on the outside I'm going to put a 5 divided by 2. Okay, now the first trapezium, the 2 lengths are 2 and 5. So add them, we get 7. And then 5 add 10, we get 15. 10 add 18, we get 28. So inside and then 18 add 28 is 46, and then 28 add 42 is 70. Okay, now using this method, my estimate is 415 meters. Given that the jet accelerated smoothly over these 25 seconds, explain whether our answer was an underestimate or overestimate to the length of runway used by the jet to take off. Alright, so if we look at the speeds, they are getting faster, quicker. So the speed over this period is exponentially increasing. So it's going to look something like that. Now, our trapeziums they have a part above the curve. So what we've done is calculated an overestimate of the actual length because we have some extra area above the curve. Number 3, so we have a sector of a circle, centre O, radius 5 centimeters and an angle 40 degrees. The student has tried to work out the area. Part A wants us to explain the student's error. So, they've used 1/2 r squared theta good times, but theta is not in radians. So, the error is that r squared theta over 2 only applies when theta is in radians. B. Write out a correct solution. Alright, so let's turn 40 degrees into radians. So theta is 40 times pi over 180. So, that's going to give us 4 pi over 18, so 2 pi over 9. Okay, so then the area is 1/2 times r squared, so 25, times 2 pi over 9. And that's centimeters squared. So we can leave it in terms of pi. The 2's cancel. So we have 25 pi over 9 centimeters squared. Number 4, the curve C1 with parametric equations. X is 10 cos t, y is 4 root 2 sin t, meets the circle C2, x squared and y squared is 66 at 4 distinct points. Given that one of these points, S, lies in the 4th quadrant, find the Cartesian coordinates of S. So, x, y coordinates. Alright, so the way that we start this is by substituting the parametrics into the circle. So that's going to give us 100 cos squared t and now 4 root 2 squared is 16 times 2, so 32 sine squared t and that is 66. Okay, we can divide through by 2. Alright, now what we need to do is get this whole thing in terms of either sine squared or cos squared. So I'm going to go for cos squared. So 50 cos squared t add 16. Now sine squared add cos squared is 1. So sine squared is 1 minus cos squared. Alright, now then, so now we have 50 cos squared minus 16 cos squared, so we have 34 cos squared t add 16 is equal to 33. Okay, take away the 16. Now we get 34 cos squared is equal to 17. And then that's really nice. If we then divide by 34, cos squared t is 1/2. Now, let's go back to where S is. So we can see the x coordinate is positive, and the y coordinate is negative. So, given that x is the cos term, when we square root, we only care about the positive. So, cos t is positive the square root of 1/2 only. So that is 2, no it's not, it's root 2 over 2. Now, from that we can work out the x coordinate of S. Because we know x is 10 cos t. So x is 10 root 2 over 2, so that's 5 root 2. Alright, now we need to find out what sine of t is. So, we know that cos squared of t was 1/2. Cos squared is 1 minus sine squared. So, from that, we also get sine squared is 1/2. Okay, now again, we are going to square root. So, this time, the y coordinate is negative, so we only want the negative answer to the square root. So we get sine of t is a negative root 2 over 2. So, now we know that at S, y is 4 root 2 times minus root 2 over 2. So that is going to give us minus 4. So S is 0.5 root 2 minus 4. Number 5, so we have the curve y is root x. The point B, xy, lies on the curve. The rectangle has a height y and width delta x. We want to calculate the limit as delta tends to 0 of the sum from x is 4 to 9 of root x delta x. So all that this is integration. Integrals are sums of an infinitely tiny amount. So this rectangle, as delta tends to 0, the rectangle is infinitely slim. Integration sums up all the areas of these infinitely thin rectangles. So all that this is the integral from 4 to 9 of root x dx. So, root x is x to the 1/2. So that integrates to x to the 3/2, and then we divide by the new power. So we get 2x to the 3/2 over 3. Between 4 and 9. So, 9 to the 3/2 is 27. So 2 times that, 54. Divided by 3 is 18. Now, 4 to the 3 halves, 2 cubed, so that's 8, times 2 is 16, divided by 3 is 16 thirds. So, we have 54 thirds minus 16 thirds. So that is 38 thirds. Number 6. So this time we have a sketch of g of x, where g of x is a piecewise function. So, for x less than or equal to 2, g of x is x minus 2 squared add 1. And for x greater than 2, g of x is 4x minus 7. But they want us to calculate g of 0. So, g of 0 means g of 0. So, g of 0 is going to be minus 2 squared add 1. So that's 4 add 1, which is 5. Okay, so now we are putting x equals 5 into g of x. So now g is 4x minus 7. So that's 20 minus 7, which is 13. Part B. Find all the values of x such that g of x is greater than 28. Okay, so we need to consider both parts of the function. So let's do the quadratic first. So, we want to solve them. X minus 2 squared add 1 is greater than 28. Alright, now I'm going to think about where it equals 28 first. So, let's say we're going to subtract 1. So, x minus 2 squared would equal 27. Now, we know the quadratic is going to have a y-intercept of 1, so we are only interested here in x being negative. So, when we square root, we only care about minus root 27. So, x minus 2 is minus root 27, which is minus 3 root 3. So, that would give us that x is 2 minus 3 root 3. Now, what we really want is where is that greater than 28. So that's going to be everywhere to the left of that point. So, that tells us then that x is less than 2 minus 3 root 3. Sorry, 2 minus 3 root 3. Alright, now on the other side, we then need 4x minus 7 to be greater than 28. So, add 7 divided by 4, we get x is greater than 35 quarters. So, our two answers are that x is less than 2 minus 3 root 3, or x is greater than 35 quarters. Okay, then we're told h is defined by h of x is x minus 2 squared and 1, for x less than or equal to 2 only. Part C. Explain why h has an inverse, but g does not. So, to have an inverse, a function must be 1 to 1, which means one y value maps to one x value only. Now, h of x is just the left-hand part of g of x, so the quadratic. So h is 1 to 1. G of x, though, most of the time, except when x is 2, but most of the time, g of x is many to 1, because one y value can map to 2 x values. So g does not have an inverse, but h does, because it's 1 to 1. And then the final bit, solve h inverse of x is equal to minus 1/2. So, there's a few ways that we can do this. The way that I'm going to do it is by undoing the inverse. So the way that we do that is take the function of both sides. We do this all the time with exponentials and logs. So, if we take h of h inverse, we just get x. And on the right, we get h of minus 1/2. Now that gives us then x is minus 1/2 minus 2 squared, so that's minus 2.5 squared, add 1. Now that gives us 7.25. Number 7. A factory makes small bars of soap. On any day, the total cost £5 to the factory of making X bars of soap can be modelled as the sum of the cost of two separate elements. So we have a fixed cost and then an amount proportional to the number of bars made that day. Part A. I write down a general equation linking y and x in this model. So, y is the total cost. Now the amount or the cost proportional to the number of bars made, we could say is mx. And then the fixed cost is a constant, so C. Okay, then we're told the bars of soap are sold for £2 each. On a day when 800 bars are made, they make a profit of £500. On a day when 300 are made and sold, they make a loss of £80. Part B. Show that y is 0.84x. Add 428. Alright. So, this is simultaneous equations. Profit is money that you make minus your cost. So, from the first bit, we know that 500 is made by selling 800 bars at £2 each. So that's £1,600. Now x is 800, so this is minus 800m minus c. And then in the second part, a loss of £80 is a minus 80 profit. Now that comes from selling 300 bars at £2 each, so 600. Minus 300m minus c. Alright, so we're going to get rid of the c's and find m. So, let's subtract the bottom from the top, so we get 580 is 1000 minus 500m. So, add 500m and subtract 580. And then 500m is 420. Divide by 500, and we get m is 0.84. So at this point, we know that y is 0.84x and c. Alright. Now we're going to use that in one of these equations. So I'm going to put it in the top one. So now we know 500 is 1600 minus 0.84 times 800, so that's 672 minus c. So we're going to add c. Now on the right at the moment we have 928. We then subtract 500 and we get c is 428. So finally y is indeed 0.84x at 428. C. With reference to the model, interpret the significance of the value of 0.84. Alright, so we know before the factory even starts making bars of soap, there's a fixed cost of 428 pounds. Now, the cost increases for every bar made. Now, because the number of bars is being multiplied by 0.84, that's telling us that each bar costs 84p on top of the fixed cost. So it's telling us each bar of soap costs 84p to make on top of the fixed cost per day. And the final part, assuming that each bar is sold on the day it's made, find the least number of bars they need to make on any given day so that they make a profit. Alright, so we know the money made is 2x. And the cost is 0.84x at 428. So, profit is money made minus the cost. So, 2x minus 0.84x minus 428 must be greater than 0. From that we can get 1.16x is greater than 428. Divide by 1.16 and we get x must be greater than 368.9. So that tells us then at least 369 bars need to be made. Number 8a. Find the value of the sum from r is 4 to infinity of 20 times 1/2 to the power r. Alright. So, what this is, it's an infinite sum of a geometric series. So, I've rewritten it using n instead of r, because we need r in the geometric sum. It's really annoying that they use r in the question. They also did this in paper 1. Stop doing this, Edexcel. Right, so, this sum is 20 times 1/2 to the power 4 and 20 times 1/2 to the power 5 and then that goes on forever. So, our first term is 20 times 1/2 to the power 4 now that gives us a 1.25. And then the common ratio r, so what we're multiplying by from term to term is 1/2. Now we are given the formula for the sum to infinity, so it's a over 1 minus r. So sum to infinity is 1.25 divided by 1/2. And that is 2.5. At B, show the sum from n is 1 to 48 of log base 5 of n add 2 over n add 1 is 2. Alright. So, let's call this S48. So, that's going to be a log of 3 over 2. And a log 4 over 3. And then that's going to continue all the way up to the log of 50 over 49. Alright, now when we add logs together, we multiply the insides. So this, as a single log, is log base 5 of 3 times 4 times 5 all the way up to times 50 and then on the bottom there we have 2 times 3 times 4 times 5 all the way up to times 49. Now, the top and bottom have a common factor of 3 times 4 times 5 all the way up to times 49. So, they cancel. So, we have the log of 50 on top and 2 on the bottom. So that's a log base 5 of 25. Which is asking what power do we set 5 to get 25, which is indeed 2. Number 9. A research engineer is testing the effectiveness of the braking system of a car when driven in wet conditions. They record the braking distance d meters of the car when the brakes are applied from a speed of v kilometers per hour. The graphs of d against v and log 10d against log 10v were plotted. So we have the graphs and then a data point on each graph. Part A. Explain how figure 6 would lead the engineer to believe that the braking distance can be modelled by d is equal to kv to the n, where k and n are constants, and k is approximately 0.017. Alright, so that graph is of the form log 10d is equal to n log 10v add c. So n is the gradient of the line. Now we know that c is the vertical axis intercept, so here that's minus 1.77. Alright, now n log v can be written as a log v to the power n. Alright, now we can get the logs on the same side, so I'm now going to subtract a log v to the n. So when you subtract logs, we divide inside. So on the left, we're going to get a log 10 of d over v to the n. Is equal to minus 1.77. Now, to cancel the log, we raise both powers both sides as a power of 10. So, d over v to the n is 10 to the minus 1.77, which is roughly 0.017. So then, finally, d is approximately, actually, just going to use equals, so d is equal to 0.017 v to the n. Part B, using the information from figure 5, find a complete equation for the model giving the value of n to 3 sig figs. Alright, so in figure 5 we know that when v is 30, d is 20. So we're going to get 20 is 0.017 times 30 to the power n. Alright, so first up, divide through by 0.017 and we are going to get 176.5 Now take logs on both sides, so I would use ln log. So on the right, log of 30 to the power n is n log 30. So n is log 176.5 divided by log 30. Okay, now we want that to 3 sig figs, so that is going to be 2.08. So the complete model is D is 0.017 times V to the 2.08. One is driving at 60 kilometers per hour in wet conditions when he notices a large puddle in the road 100 meters ahead. He takes 0.8 seconds to react and apply the brakes. use your formula to find out if Sean stops before reaching the puddle. Alright. So, we need to work out how far he travels in the 0.8 seconds before applying the brakes. So, 60 kilometers per hour is 60,000 meters in 3,600 seconds. Now that is to one decimal place 16.7 meters. In 1 second. Multiply that by 0.8 and we get 13.3 meters. Alright, so that's how far he travels before applying the brakes. Now we want to find the distance he will travel when the brakes have been applied. So now we know t is 0.017 times 60 to the 2.08. So that gives us 84.9 meters. Now his total is then 98.2 meters. Which is less than 100 meters. Therefore, he does stop in time. Okay, number 10. So we have a triangle OAB. The point C is such that O to C is 2, O to A. The point M is the midpoint of AB. The straight line through C and M cuts O to B at point N. Given that O to A is A and O to B is B, part A, find C to M in terms of A and B. Alright, so the first thing I would do is put all of the information on the diagram like this. So, part A, we want to get from C to M. So, for that, we are going to need to go from C to A and then halfway from A to B. So we have C to A add 1/2 a to b. Alright, so c to m, that's minus a, and then it's plus 1/2. So, to get from a to b, we go minus a, add b. So, that then is minus 3/2 a, add 1/2 b. B, show that O to n is 2 minus 3/2 lambda a, and 1/2 lambda b, where lambda is a scalar quantity. Alright, so to get from O to n, we're going to have to go from O to C, and then some amount along C to M. So we don't know what that amount is. That's where a lambda comes in. So, O to N is O to C plus lambda C to N. So, that's 2a, and then minus 3/2 lambda a, and then plus 1/2 lambda b. So, in terms of a, we have 2 minus 3/2 lambda a, plus 1/2 lambda b. Hence, prove that O(n) to NB is 2 to 1. Alright, so, we know that because n is on the way to b from O, it should only have a b component. So that means, in what we just found above, the a component needs to be 0. So, we know then that, so let's say that O to n is only some amount of b, so let's call it kb. So, that means that 2 minus 3/2 lambda must be 0. Now, from that, we can get that lambda is 4/3. So that means that O to n is 1/2 times 4/3 b. Now that is 2/3 b. So that must mean that n to b is 1/3 b. And therefore O(n) to nb is indeed 2 to 1. So here we have the curve y is x to the x for x greater than 0. Part A, find by first taking logarithms the x-coordinate of the turning point of C. Alright, so y is x to the x. Now, we need to differentiate, so the only log we can differentiate is ln log. So let's take that on both sides. So we get log y is a log of x to the x, which is x log x. Okay, now it would be a good time to say that at the turning point dy by dx is 0. Alright, so we need to use implicit differentiation on the left and the product rule on the right. So, on the left, think of y as a function of x. So if we differentiate the inside, we get dy by dx. And then if we differentiate the log, we get 1 over y. Okay, now on the right, using the product rule, we differentiate the x and not the log x, so we get the log x. And now we differentiate log x and not x. So the derivative of log x is 1 over x. So we have x over x, which is 1. Alright, so now multiply through by y. So dy by dx is y times log x add 1. Alright, so now we're going to set the right hand side equal to 0. So that tells us either y is equal to 0 or log x add 1 is 0. But y is x to the power x, which can never equal 0. So, we're dealing with log x add 1 is 0. So, log x is minus 1. Now, exponentiate both sides, and we get x is e to the minus 1. Or 1 over e. At B, the point P alpha 2 lies on C. Show that alpha is between 1.5 and 1.6. Alright, so again we know y is x to the x. Now what we want is when we sub in x is 1.5 and 1.6, we want 1 to be smaller than 2 and 1 to be bigger than 2. So 1.5 to the 1.5 gives us 1.8 and 1.6 to the 1.6 that gives us 2.1. Okay, so 2 is between 1.8 and 2.1. Now, we also need to say that the curve is continuous in this interval. So we would say the curve is continuous for x between 1.5 and 1.6 and 2 is greater than 1.8 and less than 2.1. Therefore, alpha is indeed between 1.5 and 1.6. C. A possible iteration formula that could be used to find alpha is xn add 1 is 2xn to the 1 minus xn. using x1 is 1.5, find x4 to 3 decimal places. Alright, so on your calculator, put in 1.5 and press equals. Now, to find x2, put in the iteration formula. Now, wherever there is an xn, press the ans button, ANS, down the bottom. So you want to put in 2 ans to the 1 minus ans. Press equals, and that will give you x2. So that is 1.633. Press equals again, and we get 1.466. And then one more time, and we get x4 is 1.673. But D, describe the long-term behavior of xn. So, if we keep going on our calculator, we can see every time we press equals, we're getting further below 1.5 or further above 1.6. So, the first thing we would want to say is that xn is divergent and if we keep going, it gets closer and closer to 1 on the bottom end and closer and closer to 2 on the upper end. So we would say it oscillates between 1 and 2. A. Prove that cos 3 theta over sin theta and sin 3 theta over cos theta is identical to 2 cot 2 theta. Alright, so if we add the fractions, then to get common denominators, we need to multiply the first one by cos theta on top and bottom, and the second by sin theta on top and bottom. So that's going to give us cos 3 theta times cos theta add sin 3 theta sin theta all over sin theta cos theta. Alright, now the top we can use the compound angle formulas to rewrite it. So we have a plus between the two terms, and it's a cos plus sin. So we're looking at cos of A minus B. So up on top we can say that A is 3 theta and B is theta. So we can say the top is cos of 3 theta minus theta over sin theta cos theta. Alright, so the top is cos 2 theta. Now, for the bottom, we need to remember that sine of 2 theta is 2 sin theta cos theta. So, sin theta cos theta is 1/2 sine 2 theta. So, that means we have cos 2 theta over 1/2 sine 2 theta. Now, dividing by 1/2 is the same as multiplying by 2, and cos over sine is cot. So this is 2 cot 2 theta. Solve for theta between 90 and 180 degrees, cos 3 theta over sin theta and sin 2 theta over cos theta is equal to 4, giving any solutions to one decimal place. Alright, so we know then the left can be written as 2 cot 2 theta. So, divide through by 2 and we get cot 2 theta is 2. Now, cot is 1 over tan. Now, from that we can get tan 2 theta is 1/2. So, if we now inverse tan, we get 2 theta is 26.6 degrees. So, from that, theta would be 13.3 degrees. But we want theta between 90 and 180. Now, the period of tan is 180 degrees. The period of tan to theta then is half of that, so 90 degrees. So to get to our next solution, we just add 90 degrees. So theta is 103.3 degrees. A manufacturer produces a storage tank. The tank is modelled as a hollow cylinder closed at one end with a hemispherical shell at the other end. The walls of the tank are assumed to be of negligible thickness. The radius of the cylinder is r meters, and the height is h meters, and the radius of the hemisphere is r meters. The volume of the tank is 6 meters cubed. Part A. Show that, according to the model, the surface area of the tank is 12 over r add 5/3 by r squared. Alright then, so the surface area, let's call it A. So we have a circular base, so that's pi r squared. We also have a hemisphere, or the outer curved part of, so that's half of 4 pi r squared, so that's 2 pi r squared. Okay, now we have the outer body of the cylinder. So the length of the cylinder is the diameter of the circle, so that's 2 pi r, and then the area is 2 pi r h. Alright, so at the moment we have 3 pi r squared add 2 pi r h. Now, the way that we want it, we don't want h involved. So, we now need to work out what h is in terms of r. Now, so to do that, we are going to use the volume. So, we know the volume is 6 meters cubed. Now, the volume is also half of the hemisphere, so that's 2/3 pi r cubed. Add the volume of the cylinder, so that's pi r squared h. Now we know that that is 6. So we want to get h on its own. So we can get pi r squared h is 6 minus 2 pi r cubed over 3. Now, we divide through by pi r squared. So, h is 6 over pi r squared minus, the pi cancels, and r cubed divided by r squared is r. So we have minus 2r over 3. Okay, now we sub that into our surface area. So A is 3 pi r squared add 2 pi r times 6 over pi r squared minus 2r over 3. Alright, so we have 3 pi r squared plus, so 2 pi r times 6 over pi r squared is 12 over r. And then 2 pi r times minus 2r over 3 is minus 4 pi r squared over 3. Alright, so we have then 12 over r. Now, 3 pi r squared in terms of thirds is 9 pi r squared over 3. And then we have minus 4 pi r squared over 3. So, finally, the surface area is indeed 12 over r at 5 thirds pi r squared. The manufacturer needs to minimize the surface area of the tank. Part B. Use calculus to find the radius for which the surface area is a minimum. Alright, so first up, I've rewritten area as 12 r to the minus 1 and 5 pi r squared over 3. Now, for a minimum, dA by dr is 0. So we should probably say that. Alright, so 12r to the minus 1 differentiates to minus 12r to the minus 2, or minus 12 over r squared. And then 5 pi r squared over 3 is 10 pi r over 3. And that is 0. Alright. So now we want to find r. So we can add 12 over r squared to both sides. So 10 pi r over 3 is equal to 12 over r squared. Now I'm going to multiply through by r squared and 3. So 10 pi r cubed is equal to 36. So r cubed is 36 over 10 pi. So then r is the cube root of that. Which to 3 sig figs is 1.05 meters. Now, sometimes these questions also want us to check that this would give a minimum. So, the way that we can do that is by finding the second derivative. So, minus 12l to the minus 2 differentiates to 24r to the minus 3, or 24 over r cubed. And then 10 pi r over 3 is just 10 pi over 3. Now, that is all positive, so we can see that r being positive means that the second derivative is positive. Therefore, r as 1.05 does indeed give us a minimum. C. Calculate the minimum surface area, giving your answer to the nearest integer. Alright, so all that is plonking r as 1.05 into a. So, do that. Oops. So, a of 1.05 should give us 17.2 blah blah blah. So, to the nearest integer, a is approximately 17 meters squared. Final question, and she's a beaut. So, part A, use the substitution. U is 4 minus root h to show the integral of dh over 4 minus root h is minus 8 log mod 4 minus root h minus 2 root h add k, where k is a constant. Alright, good times. So, let's start then with u is 4 minus h to the power 1/2. So, du by dh is minus 1/2 h to the minus 1/2. So that is minus 1 over 2 root h. Okay, now from that, we're trying to work out what dh is. So, we can get then that minus 2 root h du is equal to dh. Now, on the left, it's a problem there that we still have a h. So, we need to turn that into something to do with u. So again, we know that u is 4 minus root h so root h is 4 minus u so minus 2 root h is 2u minus 8. So that means that dh is 2u minus 8 du. Alright, so now that we know that, we can now say then that the integral of dh over 4 minus root h is the integral of 2u minus 8 du over u. So that is the integral of 2u over u, so that's 2 minus 8 over u. du. Alright, so that's gonna give us 2u minus 8 log u add c. Okay, so now we're going to turn the u's back into h. So, now, whatever you put into a log, it must be positive. So that's where we get the mod 4 minus root h. So we have minus 8 log mod 4 minus root h now 2u can be minus 2 root h add 8. Add c. Now, 8 and c are both constant, so they can absorb into each other and become one constant k. So, finally, we do have minus 8 log mod 4 minus root h minus 2 root h add k. Then for part B, a team of scientists is studying a species of slow-growing tree. The rate of change of height of this tree may be modelled by dh by dt is t to the 0.25 4 minus root h over 20, where h is the height in meters and t is the years, or the number of years, since the tree was planted. Part B. Find, according to the model, the range of heights of these trees. Alright, so let's think about it. So, we have the rate of change of the height of the trees. Now we know when a tree is a seed, its height is 0. What about its max height? So its maximum height is reached when it stops growing. So the tree will reach its maximum So let's call it h max when dh by dt is 0. So that means that 4 minus root h must be 0. So that tells us that h is 16. Or h max is 16. So the range of heights is h can be anything from 0 to 16 meters. And the final part. So one of these trees was 1 meter tall when it was first planted. Initial condition: t is 0, h is 1. Calculate the time it would take this tree to reach a height of 12 meters, giving your answer to 3 sig figs. Alright, so what the initial condition allows us to do is to solve the differential equation. So we're going to be able to find the value of k. So we know then dh by dt is t to the 0.25 times 4 minus root h all over 20. Now we're going to get the h's on one side and the t's on the other. So we're going to get dh over 4 minus root h is t to the 0.25 over 20 dt. Okay, now we are going to integrate on both sides. So, on the left, we know we get minus 8 log mod 4 minus root h minus 2 root h add k. Now on the right, t to the 0.25 is going to be t to the 1.25 and that's now over 25. Now there's no constant on the right because we have it on the left. Alright, so now we know that when t is 0, h is 1. So that's going to give us minus 8 the log of 4 minus 1, so that's 3, so we don't need the mod. So minus 8 log 3 minus 2 add k is 0. So that tells us that k is 8 log 3 add 2. Alright, so now we know that minus 8 log mod 4 minus root h minus 2 root h add 8 log 3 add 2 is equal to t to the 1.25 over 25. Now, we want t when h is 12. So now we're putting h is 12 into this. So, now we get minus 8 log mod 4 minus root 12 minus 2 root 12 add 8 log 3 add 2 is t to the 1.5 over 25. Alright, so now we can work out the left hand side as a number. Now, on the left, we should get that as 8.85. Multiplied through by 25, and we get 221.3. Okay, one more time, take the 1.25th root of both sides, and we get t is 75.2 years. Okay then guys, there's that one done. In my opinion, that was a very tricky paper. I really hope it's helped. I'm gonna do paper 3 now, so hope to see you there. Good luck in your exams. Take it easy. Take care.